A difference equation is an equation that recursively defines a sequence of numbers, provided an initial condition. For example, y of k is equal to y of k minus 1 plus y of k minus 2. So in this example, y of k is dependent on the previous two values of y of k. At 0, we don't know the previous two values, so we have to define initial conditions, y of negative 2 and y of negative 1. In this example, we'll set y of negative 2 equal to 0 and y of negative 1 equal to 1. Now we can solve this relationship starting at k equals 0. So at k equals 0, we'd have y of negative 1 plus y of negative 2. Looking at our initial conditions, we know that's 1. Next, at k equals 1, we'd have y of 0 and y of negative 1. So looking back and at the initial conditions, we'd find that's 2. And then we look at y of 1, y of 0. Looking back at our chart, we know that's 3. And we continue on with our chart, adding up the previous two values to get the next value. And if you look, the pattern starts to emerge, and it's pretty obvious this one is the Fibonacci sequence. In this next example, we'll look at y of k with an input, x of k. So in this example, y of k is equal to 2 x of k minus 1 minus y of k minus 1. We'll set the input x of k equal to the ramp function k times u of k. We also need an initial condition y of negative 1, which in this example we'll set to 0. So at k equals 0, we'll plug that into that first equation, and we can start gathering values, looking at previous values of y of k, and also that input, x of k, which is that ramp function. And a pattern will start to emerge in this one, which is 0, 0, 2, 2, 4, 4, 6, 6, adding 2 every other time. So a useful skill is being able to convert a differential equation into a difference equation. This utilizes the limit definition of the derivative. It says that f prime of x is equal to f of x plus delta x minus f of x over delta x as delta x approaches 0. So if we shift that by negative delta x, we get a more useful format for what we're trying to do when turning a differential into a difference equation. So we'll look at an example of a differential equation. So in this example, we'll have y prime of t plus y of t is equal to 0. Using that previous definition of the derivative, we have y prime of t is equal to y of t minus y of t minus delta t over delta t. Plugging that into the equation, we have y of t minus delta t plus delta t y of t is equal to 0. Now to sample this, we're going to let t equal to k delta t, and as we know, y of k delta t is equal to y of k, the sampled function. So if we plug all that in, we have y of k is equal to y of k minus 1 over 1 plus delta k. Hope this has been very helpful.